Okay, Assalamualaikum and very good morning everyone. So now today we are going to enter homogeneous equation. So you have learned separable equation before. So there's a different step in the beginning, but then at the end the step is just the same as in separable equation. Okay, so for homogeneous equations, so initially you need to check for the homogeneity. So how to check for the homogeneity? So given in the question is this one. So you are given fxy is equal to dy over dx. So to check for the homogeneous, you need to make sure that f lambda x lambda y is equal to fxy. Okay. So if it is equal, so means that we can conclude that your equation is homogeneous. Alright. Once you already confirm that your equation is homogeneous, so you need to make a substitution of y is equal to vx. Okay, substitute y is equal to vx. Then we substitute dy over dx is equal to v plus x dv over dx. So how we get this one? This one we get by differentiate both sides. Okay, we differentiate both sides with respect to x, so we get this one. Okay, we will get this one. Okay, so next, after you do the substitution, then you perform steps of separable equation where you separate the variable of x and also v, then you integrate both sides, and then if initial condition provided, then you need to find the value of the constant. But then if not, so meaning that okay, your final answer will be in term of C. Okay, so basically this is the 5 steps to solve the homogeneous equation. Alright, so let's go to the example 1 here. So for the example 1, they just ask you to determine whether this one is homogeneous or not. Okay, so to determine whether this equation is homogeneous, so you need to check for the homogeneity. So how to check for the homogeneity? So you need to make sure that fxy is equal to f lambda x lambda y. Okay, so if it is equal, so it is homogeneous. So now, alright, now we want to find f lambda x lambda y. So just substitute lambda x inside x, then substitute lambda y inside y. Okay, after you substitute, then you try to cancel out whether you need to see whether you can cancel out the lambda or not. So for this one, we can cancel out. So once you cancel out this one, so you will get this one only. So this one is equal to fxy. So meaning that you can conclude that your equation is homogeneous. Okay, alright, so let's go to B. So given in the questions is this one. So you want to check the homogeneity. So we do f lambda x lambda y here. Okay, we substitute lambda y inside y, substitute lambda x inside x. Okay, then you see whether you can cancel out the lambda or not. So for this one, you can cancel this one, cancel this one. So this one we cannot cancel. So meaning that this one is not equal to fxy. So we can conclude that your equation is not homogeneous. Okay, so this is just for you to check for the homogeneity. So let's go to the questions. Alright, so this one they ask you to solve the homogeneous equation. So meaning that it is clearly stated that this equation is homogeneous. So no need for you to check for the homogeneity anymore. Okay, you can just proceed with the substitution. So because we already confirmed that this equation is homogeneous already, okay? So we use the substitution of y is equal to vx, and then dy over dx is equal to this one. Okay, so this is from the equation, from the questions. So you make dy over dx as the subject. Okay, and then you substitute this one inside this one. Okay, so we become like this. Okay, then alright, then you need to substitute y is equal to vx inside your y here. Okay, so you will get this one. Okay, so substitute y is equal to vx. Alright. So then you try to simplify. So when you simplify, this one is separable. You know that this one can be separable. You can separate it. So you separate the variable and then you integrate both sides. So when you want to integrate this one, class, please, okay, not everything of integrate of 1 over something will become ln. Okay, no, class. Okay, so what you need to do is this one, you have this one, so you bring it up, so become v negative 2, and then you integrate this one. Okay, once you integrate, so you obtain this one. Okay, this is not your final answer yet. Okay, you cannot leave your answer as v. Okay, what you need to do is, we know that our y is equal to vx. So it means that our v is equal to y over x. So you need to substitute this one inside this one back. Okay, so you get negative xy is equal to ln x plus c. So make y as your subject. So you will get this one. Okay, since for this question, we don't have the initial condition given. So your final answer we have in terms of c. Okay, we have c inside. Okay, so here, there's some note here. So non-homogeneous can be reduced to a homogeneous equation by using the right substitution. Okay, that one is correct. Okay, alright. So now we want to go for the example 3. Okay, for the example 3. So this is the example that use the substitution. Okay, because in the beginning, the equation is non-homogeneous. So in order for us to solve by using the homogeneous equation, so we need to do substitution. So here, given x is equal to x plus 3, and then y is equal to y plus 2. Okay, so now, since we have the substitution there, so meaning that we need to differentiate the given substitution with respect to the variable. Okay, with respect to the variable. Alright, so now we have x is equal to x plus 3. So you differentiate with respect to x. So you're gonna get, so dx is equal to dx. Okay, so now you have another one, y is equal to y plus 2. So differentiate with respect to y. So you get 1. So become dy over dy. Okay. Okay, next. Once you already perform that one, so you substitute what you have here inside your original dA. So substitute into your dE. Okay, so dy over dx will become dx. So now y small y become y plus 2. So this one become okay. So we simplify, so become y. Okay. So once you have this one, okay, so we are going to proceed with homogeneous solution. In the solution, so we have and okay, so this is the substitution for the homogeneous. So we are going to substitute inside our equation that we have. So become so y is equal to vx. So we substitute inside here. Okay. So now you simplify it. Okay. So this one is equal to so become simplify again. Okay, so now you separate the variable. One plus v. So you can see that it can be, this one is separable. Okay, separable. So once you can separate it, so you integrate both sides. 1 plus v okay, integrate that one. So you get okay, so you get negative 1 over v plus ln v is equal to negative ln x plus with c. Okay. Alright, so we rearrange, make ln with ln. Okay, so this is law of ln. Okay, so we want to eliminate the ln. So we exponent both sides. So we have this one. So e exponent of constant, so we can EC, we can make it as A only, okay? Okay, so next, okay, don't leave your answer like this. So you need to substitute back your V. V is equal to Y over X. Okay, so substitute back. Okay, so now make Y as your subject. Okay, so then Y, already know Y is equal to Y minus 2 here. So we substitute back, okay, substitute back. So you have Y minus 2 is equal to A, E, Y minus 2. Okay, so make Y as your subject. So Y minus 2. So plus with 2. So this is your final answer, right? So this is your answer. Okay, so for substitution, remember once you perform the substitution before, so you need at the end, you need to substitute back the real value. Okay, so this is how we perform for this example. Alright, for this example. So now you already see the example of how to solve homogeneous equation with substitution and also without substitution. Okay, with substitution and also without substitution. Okay, alright. So let's go to this one, the past question. So let's do number 1 here. Okay. So for number 1 here, they ask you to show that the differential equation of this one is homogeneous, hence finds its solution. So for this questions, this one is 7 marks. Alright, 7 marks. So we need to check for the homogeneity first. Okay, check for the homogeneity first. So your fxy is equal to x. So x squared minus with y squared plus with y squared over with xy. Okay. So now we want to find f lambda x lambda y. So substitute inside here. Okay. So plus with lambda squared y squared over with lambda x lambda y. Alright. So now we want to cancel down the lambda. Okay, cancel down the lambda. So this one become lambda squared. So x squared minus with y squared plus with y squared. So lambda squared. So here is xy. So we are going to cancel the lambda. So it means that this one is equal to fxy. So we can say that this one is homogeneous. Okay, so shown. Okay. Alright. So next. So once we confirm already that this equation is homogeneous, so now we want to make the substitution. So y is equal to vx, and another one is dy over dx is equal to v plus x dv over dx. Okay. So you substitute inside the equation. So you have this one. Okay. Alright. So simplify. So 1 minus b squared. So x squared v. Okay. So now try to see. This one can be cancelled out. So we have okay. Alright. So now we are going to separate the equation. So we separate the equation. So separable. Okay. So now we're going to integrate both sides. So this one, you can use substitution. Okay, use substitution. So using substitution, so we let u is equal to 1 minus v squared. So du is equal to negative 2v dv. Okay. So we substitute inside. Alright, so you integrate this one. This one become ln x plus with c. Okay, so now you cannot leave your answer like this. You substitute back what is your u. So our u is okay, this one. But then there's v. Okay, so substitute v is equal to y over x. Okay, this one substitute back. So means that your final answer become so here you go. This is your final answer. Okay, done. Okay, so it's normal, okay, to solve one question in differential equation. The solution is quite long, alright, so don't get shocked. Okay, it's normal, okay. Okay, so this is how we solve for this equation. Alright, so actually it's not difficult. So basically to solve homogeneous equation, there's 5 steps that you need to follow. First thing first, you need to check for the homogeneity. How to check for the homogeneity? You need to make sure that your fxy is equal to f lambda x lambda y. Okay, once you confirm that your equation is homogeneous, then you need to make a substitution with where your y is equal to vx. Okay, y is equal to vx, and then your dy over dx is equal to v plus x dv over dx. Okay, then alright, after you perform the substitution, so you make it into separable equation. So you integrate both sides, and then once you integrate both sides, then you get the answer. And if the question provide you with the initial condition, so you need to find the value of c. But then if they don't provide, so means that your final answer is equal, there will be c term inside. Okay, so basically this is how we solve homogeneous equations. So here we have, I left 2 questions for you to try. Okay, please try this one, see whether you can do or not. Okay, so thank you class for today.